Hello guys, welcome to our YouTube channel Engineers World. This is the fourth lecture of engineering mathematics. In this lecture we will discuss about eigenvalues and eigenvectors. Okay, this topic is also important from the gate point of view. Actually, usually in each year you will find one or two questions from eigenvalues and eigenvector, mostly from eigenvalues and sometimes also from eigenvector. Okay, so let us discuss what are eigenvalues and eigenvectors. So first we discuss about eigenvalue. Okay, let us consider we have a square matrix A of order n cross n. Okay, and if we do this matrix, that means if we subtract this matrix like this, A minus lambda I, okay, this will be one other matrix where I is a unit matrix. Okay, and after doing that, if we take a determinant of this matrix, that is determinant of A minus lambda I matrix, and equate to 0 that means we are going to find the determinant of this matrix and equate that determinant to the 0. So after doing that, we will it will form like equation there. Okay, one equation will be formed, and that equation is known as a characteristic equation. Okay, so we know for every equation there are some roots. Okay, so roots of this equation or characteristic equation are known as characteristic roots, or what we call as eigenvalues. There are 2-3 names for them: characteristic roots, eigenvalues, and one more is latent roots. Okay, so what are eigenvalues? Eigenvalues are roots of the characteristic equation. So what is a characteristic equation? Characteristic equation is nothing but it's a determinant of A minus lambda I matrix. So roots for this equation will be the values of lambda. Okay, if it is a cubic, so there will be 3 roots. If it is a quadratic, there will be 2 roots, like that. Okay, or we can say if the order is like 2 cross 2 matrix, so 2 roots will be there. Order is 3 cross 3, 3 roots will be there. Okay, so this was about eigenvalues. Now we will see what are eigenvectors quickly, and then you will see about some properties of eigenvalues and eigenvector, and then we will solve some previous year question. Eigenvector. Okay, let us consider a matrix if X is any matrix like this: x1, x2, so on, xn, and A is one more matrix: a11, a12, so on, a1n, a21, a22, so on, a2n. Same for here: an1, an2, ann. This is a square matrix of order n cross n, and here order is n cross 1. Okay, so if we perform a linear transformation on these two matrices, that is, if we do this, y is one more matrix equal to A matrix into X matrix. Okay, so here n cross n and n cross 1, so order for this will be n cross 1. Okay, so this linear, what is the linear transformation actually doing? It is doing nothing. It is converting it is converting this x vector into the vector y with the help of our given matrix, that is A matrix, or this matrix is also called as a coefficient matrix. Okay, so this transformation is going here, that means this linear transformation doing the column vector, it carries the column vector into the column vector y by means a square matrix A. Okay, so this is the linear transformation. So in practice we have to often find this, vector which transforms. So here it is transforming, x is transforming into y. So we have to find these vectors which are transforming into themselves or the scalar multiple of themselves. Okay, so these things, that vector we have to find, and those vectors are called the eigenvectors. Okay, so let us let x be as such, let x be as such a vector. Okay, x be as such vector which transforms into themselves or the scalar multiple of themselves. So here we are saying that x is such vector which transforms into lambda times x, that is scalar multiple of x. Okay, so I in the some 2 minutes before I told you that we have to find those vectors which are transforming into themselves or the scalar multiple of themselves. Okay, so here lambda is a scalar, so it is transforming x into the scalar multiple of, that means x is transforming into the lambda times x, that is scalar multiple of itself. Okay, so then we know this. So that means here y is equal to, you remember this equation, here y is nothing, it is a transformation going to the lambda times x. So lambda times x is equal to ax. Okay, so let me drop this one first. So I told you that x is transforming into the lambda times x. So we know here x was transforming into y, so here y is a lambda times x. So lambda times x is nothing equal to ax. In other words, we can say ax minus lambda times ix is equal to 0, or we can say a minus lambda I into x is equal to 0. Okay, so what is this representing actually? This matrix, these are the, so if we do this a minus lambda I into x, there will be some equations will get formed. Okay, like this. So a minus lambda I, so a11 minus lambda into x1 plus a1 to x2, so on plus a1 xn, a1n xn is equal to 0. One more will be a21 x1 plus a22 minus lambda into x2, so on plus a2n xn is equal to 0, and same for the other equations. So this is representing these equations actually. Okay, so these this matrix equation represents n. Actually, what is true? This is a homogeneous form. What is a homogeneous form of equations? That we will discuss in the next lecture. So just remember, if the system of equations is equal to 0, that in the right side there is nothing, so we call those equations as a homogeneous system of equations. So these are the homogeneous system of equations. Okay, so this homogeneous system equation will be a non-trivial solution. That also, what is a non-trivial solution? Just remember for now, that also we will see in the next lecture. What is non-trivial? Will be a non-trivial solution only if a minus lambda I is equal to, determinant of this is equal to 0. Okay, that means if the coefficient matrix, that is A, or this is a coefficient matrix here. Okay, if this is a singular matrix, what is singular matrix? That we know, if the determinant is 0. Okay, so if this is possible, that means this system, homogeneous system of equation, is a non-trivial solution. Okay. let me first so a minus lambda I, that means coefficient into equal to this. So this x, which is actually equal to, will be some x1, x2, so on, xn. This is nothing. This is an eigenvector. This we have to find. Eigenvalues we know, the roots of the characteristic equation, and after doing that, for each lambda there will be one eigenvector. Okay, that means if the matrix is a 3 cross 3 matrix, if A is of order 3 cross 3, there will be 3 values per lambda, that is for 1, 2, 3. Okay, for if we put lambda is equal to 1 here, so we will find this value of x. So that will be for corresponding to lambda is equal to 1, there will be some eigenvector. Similarly for 2 there will be another, and 3 there will be some another eigenvector. Okay, this is also called eigenvector. This is eigenvector or latent vector. Okay, so this was a definition of what is eigenvector and eigenvalue. Okay, let's take here one small example that will make you better understand this. Okay, let I have a matrix A which is equal to 2 cross 2 matrix 5, 4, 1, 2. It is saying find eigenvalue and eigenvector for this matrix. So what I told you, for calculating the eigenvector, determinant of this equation that is equal to 0, that means 5 minus lambda, 4 will be as it is, 1 will remain as it is, 2 minus lambda. Just subtract the, what this represents actually, just subtract lambda from the leading diagonal elements and equate that equal to 0. Now expanding this, that means 5 minus lambda into 2 minus lambda minus 4 is equal to 0. Okay, that will be 5 into 2, 10, minus 5 times lambda minus 2 lambda plus lambda square minus 4 is equal to 0. That means lambda square minus 7 lambda plus 6 is equal to 0. So if we do this, separating the middle term, lambda square minus 1 lambda minus 6 lambda plus 6 is equal to 0. After solving that, you will get lambda is equal to 1, 6. So the eigenvalues for this matrix are 1 and 6. So these are just the roots of this equation. It was 2 cross 2 matrix, so 2 eigenvalues. So we here lambda we got as 1, 6. Okay, now coming to the eigenvector. What I told you, for each and every eigenvalue there will be one eigenvector. So we know this, a minus lambda I into x is equal to 0. That means what this represented, 5 minus lambda, 4, 1, 2 minus lambda into, it is your choice, you represent this as x1, x2 or x as x and y. That will not make any difference. Okay, so let's calculate for if lambda is equal to 6. Okay, that means for eigenvalue 6 we will find the eigenvector. So this will become 5 minus 6, 4, 1, 2 minus 6, x and y equal to 0. So this will give us y, that means minus 1, 4, 1, minus 4. Okay, into x, y is equal to 0. So now represent in terms of equation will be minus x plus 4y is equal to 0, x minus 4y is equal to 0. These are just the same if we take the line. So this represents the just one equation. Okay, so from any of the equation, if we do this, x is equal to 4y, or we can say x by y is equal to 4. Okay, so that means if we do this, x is equal to 4, in that case y is equal to 1. So for lambda is equal to 6, our eigenvector x will be x was 4 lambda. Okay, this will be the eigenvector in that case. Okay, similarly we can calculate quickly for lambda is equal to 1. That means that if now lambda is equal to 1, okay, so this will become 5, just separate 5 minus 1, 4, 4, 1, 1, x and y is equal to 0. That means 4x plus 4y is equal to 0, x plus y is equal to 0. Same, only one. That means this is there is only one independent equation for this. So here I told you there will be a non-trivial solution if the coefficient matrix determinant is 0. You can see 4 into 1, 4, minus 1 into 4, that is 0. So it is a singular matrix. So what this represents actually, x is equal to minus y. Okay, or we can say x by 1 is equal to y by minus 1. That means in this case eigenvector will be 1 minus 1. Okay, so this is how you calculate. This is a procedure for solving the questions. What are how to calculate eigenvalues and how to calculate the eigenvector. Now we will move to some properties. There are some properties of eigenvalues and eigenvector which are really important from the competitive exam point of view. You will get questions only based on those properties, because you don't have time there to solve questions like this. If you know the properties, just apply those properties, you'll find the answer. Okay, properties of eigenvalue. Eigenvalue. First one is, if A is in the matrix whose what you call eigenvalues are from let lambda, then it is saying that what will be the eigenvalues of A transpose. That if you take the transpose of a matrix, what will be the eigenvalues? Those would be same like lambda. Okay, if it is lambda 1, lambda 2, so on lambda n, this will be value lambda 1, lambda 2, so on lambda n. That means by taking the transpose, eigenvalues doesn't change. This is example. This is one first property. Okay, second property is just eigenvalues of a triangular matrix are just the diagonal elements. That means if it is saying that find the eigenvalues of a matrix, but that matrix is in a triangular shape, that is just triangular form. Like if A is a mini matrix, 1, 2, 3, this one is 0, 4, 5, 0, 0, and 6. This is a 3 cross 3 matrix. This is a matrix, and is in question it is saying that what are the eigenvalues for this matrix. Those what is saying that eigenvalues of a triangular matrix are just the diagonal elements. So eigenvalues will be these. So lambda 1 will be for let lambda 1 1, lambda 2 4, and lambda 3 6. So the eigenvalues for a triangular matrix are, it is diagonal element. Okay, and this also says if so this is a case for triangular matrix. If the matrix is now diagonal matrix, like A is in this form, 1, 2, 3, 0, 0, 0. So this is a diagonal matrix. So in this case also lambda will be 1, 2, 3. So in both the cases, triangular matrix and diagonal matrix, eigenvalues are just the leading diagonal elements. Okay, so this was property number second. Moving to the property number third. Okay, one of the most important property, sum of eigen values of a matrix is equal to the sum of its diagonal elements. Okay, so sum of the diagonal elements will be equal to the sum of the eigenvalues of a matrix. Okay, so just remember this. This is a really important. And this property, by this property, we can solve many of the questions which have been asked in exams like GATE and ESE. Okay, and there is one more property. That is product of eigenvalues is equal to the is equal to the determinant of a matrix. We will find the determinant of a matrix that will be equal to the product of eigenvalue. Okay. Okay, and one more property is there quickly. If A is in a matrix whose eigenvalues are lambda 1, lambda 2, lambda 3, so on, lambda n, and it is saying that find the eigenvalues of A raised power m times matrix. So for this case, raised power m, lambda 2 raised power m, lambda 3 raised power m, and so on, lambda n raised power m. So just power eigenvalues with the same factor. It is 2. Just power this eigenvalue by 2, this by 2, and those will be the eigenvalues for this matrix. So these were some properties of eigenvalues. Now we will solve some. So in the next lecture we will solve some previous year questions about this eigenvalues and eigenvectors. We could have solved in this lecture only, but I think it will be length. Next lecture we will solve some previous year question. So till now just revise these things. What are just understand the basics. What are eigenvalues and eigenvectors, and just remember these properties. These will be really important and will be helpful in solving the these questions. So see you in the next lecture. Till now, if you have enjoyed this lecture, so share this with your friends, and like this video, and just subscribe our channel. Thank you very much.